Hey everybody, this is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poems. I'm back in New York. Went to a wedding actually. It was a beautiful wedding. It was a beautiful day. And now I'm back home where I probably should set up the AC. But it is very hot. Let's put it that way in my room right now. I think it's like 80 degrees outside. Fahrenheit for those of you with normal time scales, I think, or temperature scales, I think it's like 20s or something. I don't know what is it. I have to see. It's 27 degrees, and my apartment is inside is hotter. So yeah. Anyway, with that said, today's poem is prefix and suffix search. Okay, design a special dictionary with some words that are searched by prefix and a suffix. What does that mean? So apple. So you have an F function, that's A and E. So return 0. So we have to return the okay, let's see. So we have a word list, okay, that's fine. Return the index of the word in the dictionary, which has prefix and suffix. If there are more than one variant, then return the largest of them. Okay. Yeah, and each of these will be at most 10 length. I imagine my first instinct, this is obviously a data structure problem, or at least it's set up that way. For my first instinct is to have like a try, right? A try for both the prefix and the suffix. Of course, it's still a prefix try, but for the suffix, you would just process all the words on the other direction, and then maybe do like an intersection of the sets or something like that. But I don't know if that's good. In theory, that should on average case it'll be okay, right? But definitely you can construct cases where that is just not acceptable, right? So then in that case, what do we do? If like, for example, if maybe I'm actually like, for example, if the two intersection is like if I'm trying to think. The average case would be okay, but the worst case, right, is if both of them contain, say, 7,500 or 7,500 words, and they don't intersect at all. And if you do that 15,000 times, that's gonna be too slow, right? So can I do better? Definitely prefix makes sense. Can I walk that dag? It'll still be like if you zigzag, so you can't really walk the two-pointer algorithm or something like that. In a better way. Maybe it's slightly better, but yeah. So I got messaged. I don't know if this is just one of those problems where maybe the how bad is the worst case, right? Or maybe I'm missing something. Maybe the can we abuse something with the word length of 10 in a good way? Or the words unique? Let's see. I guess if they're not unique, then you just keep track of the larger index anyway, right? Because it doesn't make sense to yeah. But I don't know, the way that I was thinking about it is that I don't know if I should figure out this one for the average case or the worst case. I think that's the the tricky part. But maybe it's fine. I don't know if there's a easier way, so maybe this is fine. I don't know. Because my thing is that, like, let's say, yeah, my thing is that if you have, let's say in the AE case, right? Let's say you have, I mean, just like the set intersection, it's gonna be very expensive if none of them matches. But if it does match, you want the biggest one, so you do a linear walk. But that's still, like, the average case would be good, but the worst case may be bad, and you could keep on pumping the worst case. Let's see. I don't know. I mean, okay. Can I take advantage of the 10 in a way? Can I brute force it? Oh, can I save the answers in a good way? I wonder also, just like, if I can keep track. Maybe I can keep track in a good way, but I don't know about the timing. No, because I was thinking about a way where almost like a pre-filtering thing of like, okay, so yeah, because just getting a list of all these numbers and then removing them will already be too slow, right? Like, let's say you have a 10,000 word length, and then you kind of just you kind of yeah, you have 10,000 words, and then you maybe go down a tree with those 10,000 words and then remove them as you go, right? But even that seems too slow. Can we do intersection in a good way with respect to that? Huh. Well, okay. No. Can we take the suffix in a good place? No. I don't know. I'm a little bit stuck on this one. I mean, I'm not convinced that the double try idea is fast enough. Just because, unless I'm missing something, because this can have like a lot of words, right? I guess, like, for example, if we have, like, we can easily construct an example where, like, this is the worst case. So then you have f of, say, AE even, which is one of the examples. But then you have words that are like AE, ABE, ACE, right? Or maybe even something. No, this would be okay. But just something like, you can even just do something like A, B, A, B, A, C, dot, 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 like 10,000 of these, right? And then maybe, I mean, this is not even the worst case, I guess. Okay, you have something like this maybe, and then you have something like you know, E, A, E, well, maybe B, and then C, D, dot, 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 7,500 of these, right? So there'll be no intersection between these, and therefore it would take the full 7,500 per function call, and each function call is 15,000 times. So 15,000 times 75,000 is not going to be good enough, right? So I don't really know how to do it in a better way to do like some sort of intersection without figuring out, or like maybe I don't even like, should I YOLO? Like, is this fast enough? I don't know. I guess one way we can do it is, what is this times 100, right? So to do 1.5 million, 1.5 million times 10 is 15 million. Is that enough? Something like that, maybe 30 million. I guess maybe that's enough memory. I guess we could pre-process all the possible, for each word we can pre-process all the possible prefix and all the possible suffix, and then we can do def f of all one. The only thing I'm a little bit worried about is that so this will be fast enough. The only thing that I worry about is about memory, whether we have enough memory to do it. But let's see, right? So there are 100 prefix, 100 suffix. So we do 100 square. Well, technically 1 to 10. So I guess that is 10. 100. So that's what is it? 1.5 million, and each of them may contain up to 20 characters. So that's 30 million. And that's probably pretty okay. 30 million characters with some overhead should be okay. Okay, let's try it that way. A little bit sad that it took me that long, though, to be honest, to think about it. But there's just a lot of it. I was trying to figure out a way to do it without this thing, but maybe that's just the way to do it. I don't know. Let's give it a spin. So then now for word in words, maybe I don't need this actually, but anyway, self.lookup is equal to hash table. So then now key is equal to, let's say, well, so for I in range of length of word, and then for j in range of length of word, right? Is it maybe +1, but also starting from 1? So I is the prefix and j is the suffix. So then we have something like word of, what is it, from the first I, maybe something like this. It doesn't really matter, just some sort of, maybe just space, maybe a space is fine. And then is that j? No, it's negative j, right? Let's print this out real quick, because I'm always really bad with off by ones with these indexes. So I think this is right, but maybe I'm off by 1. AE, ALE, AP, okay, that looks okay. So yeah, okay. So then now we can do something like self.lookup of key is equal to index, right? I didn't actually do the enumerate, I forgot. And this will overwrite with later ones, so I think this will give us the largest one. So then now we have key is equal to also technically what I would recommend is actually putting this in a function, but functions in Python are expensive. This is not, so if you're doing production code, definitely put it in a function. Leetcode is slow, so Leetcode is silly, so yeah. I mean, Yeah, they don't have any it's just slow. So that's why I'm doing it this way. So, okay. If key is in sub.lookup, return, I was gonna say return -1, which is not true. We return self.lookup of key. Is this 0 indexed? I guess so. So let's give it a spin. I mean, this is a really easy thing to do. Let me see if I can, well, there's only one way. Oh, let's just give it a quick submit and see. Wow. Apparently in the past, I've done it in many ways. Okay, this time I did it, I mean, I solved it on the first try. So keeping the streak alive at 809 days, but much slower. I don't know if they added more word or anything. How did I do it previously? Let's find out. Oh, let's go over the complexity real quick. I mean, like I said, this is O of n, one for each word, times, let's say L times L, or maybe P times P, where P is the size of prefix, suffix to query, right? And then I didn't actually use as much memory as I worried about. And then here, this is just O of 1, basically, depending on how you say it. O of 1 in terms of lookup. You can maybe say O of n in terms of the size of the input and then look up it. But that's up to you. I'm curious how they did it last time. Definitely ate some things. I did do it with try. So how did I do it with try? Oh, so this is the thing where I did the set intersection. The set intersection is going to be too slow. I think I was very optimistic and I don't know why I did it this way instead of just like max. But maybe I was just 2019. I was still learning Python a little bit, or like learning. Yeah, I mean, I would say I was still learning Python. But yeah, you would just get the max. But I'm not surprised that that time limited. And then what would I do? And then I did some weird optimization, but and then I did the thing where I move one at a time, but apparently there's some like weird thing going on. I don't know. And then I got it accepted, and ultimately by I still use so the try intersection thing works. I wasn't sure that this was fast enough, to be honest. That's why I didn't. But I guess my past Larry is more confident about it. Because the thing, like I said, right, like we can construct cases where this is just too slow, and then if you do that query like 15,000 times, it's going to be too slow. But today I just wasn't. Maybe I self-doubt myself too much, and I should YOLO more. What was the hint anyway? Oops. What did I click on? What was the hint? Oh, that's basically what I end up doing. But that's not even a hint. That's just like telling you how to do it. How did I do it the second time? I did do it. Well, I did it the same idea, but I did it with much slick. No, yeah. Well, I mean, this is not a suffix. I seems like the second time I did it, I got lazy with the tree, and I just put everything in a set. But then it was the wrong answer, and then time limited, so it was too slow. So then I did what I did today, except I used a tuple instead. Is that better? I don't even know. But I got wrong answer. What did I get wrong answer? Oh, I don't know why I did it this way. But this is the wrong answer because I reversed the word. Maybe so I could write this a little bit better. Wait, what? This is just silly. I think it was just like me being careless because this should be J at the very least. So there are a couple of errors there. But then because I think because the inputs didn't test it. So there you go. And then suffix, I reversed it. So I reversed it twice. So it's a little bit silly actually. But basically it's the way that I did it today. So maybe there is more input as well. Maybe not. I mean, strings does take more time to construct. But maybe not. I don't even know. Anyway, this is a very weird problem because I think I think this is one of those problems where the constraints don't really tell you the whole story. It depends on the distribution of the inputs, which they don't really, or there's no easy way to tell. Because, like I said, I don't know. I guess I deleted it, but because you can probably break TLE most cases if you just have something like your word dictionary is A B, A C, A D, no AE, AF, dot, and then like just doesn't really matter what they are, just anything that starts with A, but 7,500 of them. And then something that ends with say ye, and then also doesn't matter what they are, as long as you have 7,500 of them and none of them with a prefix, right? And then you just run query f of a ye 15,000 times. And if you do it that way, just with time limit, because there's nothing to do, you have to do essentially a full set intersection, which is 7,500 times 2, and 15,000 times 15,000 square is gonna be too slow, so which is why I hesitant. But I don't know, sometimes you have to read minds, or YOLO and get a little lucky. Didn't do either today, so whatever. Anyway, that's all I have though. I did get it on the first try this time, so I guess that's good. Anyway, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.